The standard is ARCH.8.EE.C.7.A.8.3c. The learning target is I can analyze and solve pairs of simultaneous linear equations, also known as systems of equations, also known as a pair of equations. When two equations are on one graph, observe and analyze whether they crisscross or parallel or form the same line. Let's look at that. For these two lines, this equation goes with this line, this equation goes with this line. They do not intersect, so they are inconsistent. The solution set is empty, no solution. If you look, they have the same slope, 3x and 3x. Remember when we tried to eliminate a 3x and a 3x, we would just be left with 5 equals -1, which meant no solution. So in this case, you can see they do not intersect. On this graph, you can see that these two lines do intersect at one point, so they are consistent and independent. So if you have to find the solution, it's easy on the graph to start at 0, 0, and you can just follow over 1, down 4 is where the lines intersect. So the solution is +1, -4. And finally, when you see and analyze this graph, it appears that there's only one line, but they intersect at all points, so they are consistent and dependent. There are two lines there that share the same points. The solution is a line, which is an infinite number of points. So hint, every part of the second equation is doubled. You will see a multiple in the case of consistent and dependent graphs. So for example, y equals 1/2 x minus 4, and then if you double the y, you get 2y. Double half, you get 1, and double a -4, you get -8. So there is that pattern with consistent and dependent graphs. When solving, for example, when graphing, for example, this second one, I'm going to teach you how to plot those points when given equations. So y equals -1x minus 3 and y equals 1x minus 5 are the equations that are here and here. So the strategy I advise is that if you just let x equal 0, and you put a 0 here, then -1 times 0 is 0, and the -3 becomes your y. So you can plot that as a point. X being 0 and y being -3 gives you an ordered pair of 0, -3. So you go to 0 and go down 1, 2, 3 and plot that as a point. The next thing you want to do is let y equal 0. So if we put a 0 here, we would have -x minus 3. 0 equals -x minus 3. So we're trying to solve for x so we can plot another point. So we're going to solve for excuse me, we're going to add 3 to both sides. So plus 3 plus 3, 0 plus 3 is 3, equals negative x. So we eliminated the 3 here by adding it to a negative 3. But we don't want negative x, we want x. So we have to multiply both sides by a negative 1, because a negative times a negative is a positive. So negative x times negative 1 is just x equals negative 3. So now we have the ordered pair, negative 3, comma, 0. So we can plot that point. So we start at 0, 0, go over 1, 2, 3, and then we move up, not at all. Now remember, 2 points distinguishes a line, so we can connect those 2 points and make a line. So that's our first line. Now we're going to repeat the pattern for the other equation and graph that. So we're going to let x equals 0, so we have y equals negative 5. So now that point is 0, negative 5. So let's plot that point. So 0 is here, we don't go left or right, and we go down 5. 1, 2, 3, 4, 5, right there. And now we need another point. So if y equals 0, then we have 0 equals x minus 5. So remember, we want x alone since we decided we were going to let y equal 0. So we have to add 5 to both sides. So 0 plus 5 is 5. And now since we eliminated the 5, we have x equals 5 or 5 equals x. So now our ordered pair is 5, 0. So let's plot that point. Start at 0, 0, count 5, 1, 2, 3, 4, 5, and then we go up, not at all. So we stay right there. And now, since 2 points determine a line, we can connect those points, and we can prove to ourselves that there is a solution because these 2 lines intersect right there. And that point, if we were going to label it, start at 0, 0, you go over 1, so it's 1, comma, and then 1, 2, 3, 4, down 4 is a negative 4. So the solution to this system of equations is 1, comma, negative 4. And that completes this lesson.